What happened before the Big Bang? Are you curious to know about what was present before the Big Bang and how the Big Bang happened? The Big Bang is widely regarded as the beginning of everything. About 13.8 billion years ago, the observable universe exploded and expanded. Hello guys, welcome back to the channel All Things Space. We are back with another blockbuster video. In today's video, you are going to know about the Big Bang and what happened before the Big Bang. What were things like before the Big Bang? Can we answer it in short? No. Because it could have a long list of things, each mind-bending in its own way. I'm going to discuss in detail, but before that, if you're new to the channel, then go and subscribe so you can get more amazing videos like this. So let's start the video. The assumption of the Big Bang. The Big Bang model is based on two assumptions. The first is that Albert Einstein's general theory of relativity correctly describes the gravitational interaction of all matter. The second assumption, called the cosmological principle, states that an observer's view of the universe does not depend on the direction in which he looks, nor on his location. This principle only applies to the large-scale properties of the universe, but it does imply that the universe has no edge. So the origin of the Big Bang did not take place at any particular point in space, but all over space at the same time. These two assumptions make it possible to calculate the history of the cosmos after a certain epoch called the Planck time. Scientists have yet to determine what prevailed before Planck's time. Big Bang and expansion. When we talk about the Big Bang and expansion, it's hard not to think of an explosion that started it all, especially since we call it the Big Bang. But that's the wrong way to think about it. Galaxies move away from each other because they are carried away by space itself. Like an elastic substance, space stretches and the galaxies are carried along like corks floating along a river. So galaxies are not like shrapnel flying away from the central explosion. There is no central explosion. The universe expands in all directions and is perfectly democratic. Every point is equally important. Someone in a distant galaxy would see other galaxies moving away just like us. Different time frame before the Big Bang. This can be considered the birth of the universe and the beginning of time as we know it. Before the Big Bang, there was simply no space or time. You can't go further back in time than the Big Bang, just like you can't go further north than the North Pole. As theoretical physicist Stephen Hawking points out in his 1988 book, A Brief History of Time, even if time did not begin with the Big Bang and there was a different time frame before it, there is no information available to us from that earlier time frame, and any events that took place then would not affect our current time frame. All alleged pre-Big Bang events can therefore be regarded as factually meaningless. The Big Bang was the beginning of time. The universe has been expanding, cooling and evolving for 13.8 billion years. The beginning of this expansion, the Big Bang, was the beginning of time. But if so, those distant regions would never have reached the same temperature and density, and other basic features of the universe would also seem inexplicable. Paul Steinhardt of Princeton University says, "It all has to do with your assumption that there was a beginning of time. So why not give up on that idea of the beginning of time?" He added more. That was a simple extrapolation of Einstein's equations, assuming there was no change even when you reach energies and temperatures that have never been explored before. Most cosmologists think that something must have laid the foundation for the expansion we observe. Although they disagree on what it is, Steinhardt co-authored the standard report Cosmic Inflation, but has since turned against it, now promoting a competing model in which our universe is the final round in a perpetual cycle of creation and destruction. Other scientists are also investigating alternatives to the standard inflation theory and to Einstein's theory of gravity to fill in prehistory. New York University's Greg Gabadadze, who is an associate director of physics in the Foundation's Department of Mathematics and Physical Sciences, said, "Some alternatives are trying to provide a pre-inflationary phase. Others don't use the inflation mechanism but still have a phase that is before the Big Bang and before the conventional expansion phase. Before the Big Bang, events are unmeasurable. It is possible that before the Big Bang, the universe was an infinite piece of ultra-hot dense material, which remained in a steady state until, for some reason, the Big Bang happened. This extra dense universe may have been governed by quantum mechanics, the physics of extremely small scale, Carroll said. The Big Bang would thus have been the moment when classical physics took over as the main driver of the evolution of the universe. For Stephen Hawking, this moment was all that mattered. Before the Big Bang, he said, events were immeasurable and thus undefined. Time and space, Hawking said, are finite, but they have no borders, beginnings or endpoints, just as the planet is finite but has no edge. What was present before the Big Bang? In an interview on the National Geographic show Star Talk in 2018, Stephen Hawking said, "Since events before the Big Bang has no perceptual consequences, you might as well take them out of the theory and say that time started with the Big Bang. Or maybe there was something else worth thinking about before the Big Bang. One idea is that the Big Bang is not the beginning of time, but rather a moment of symmetry. In this idea, before the Big Bang there was another universe identical to this one, but with entropy increasing towards the past instead of the future. Increasing entropy or increasing disorder in a system is essentially the arrow of time," Carroll said. So in this mirror universe, time would be the opposite of time in the modern universe, and our universe would be in the past. Proponents of this theory also suggest that other properties of the universe would be reversed in this mirror universe. For example, physicist David Sloan wrote in the science blog at the University of Oxford that asymmetries in molecules and ions called chiralities would be in the opposite direction to what they are in our universe. Why and how would an expanding universe contract and return to a low energy entropy? A related theory holds that the Big Bang was not the beginning of everything, but rather a moment in time when the universe transitioned from a period of contraction to a period of expansion. This Big Bounce notion suggests that there could be infinite Big Bangs as the universe expands, contracts and expands again. Carroll said, "The problem with these ideas is that there's no explanation for why or how an expanding universe would contract and return to a low entropy state." Carroll and his colleague Jennifer Shen have their pre-Big Bang vision. In 2004, physicists suggested that the universe as we know it might be the offspring of a parent universe from which a bit of space-time has been ripped off. Carroll said, "It's like a radioactive nucleus decaying. When a nucleus decays, it spits out an alpha or beta particle. The parent universe could do the same, except instead of spewing out particles of baby universes, perhaps infinitely. It's just a quantum fluctuation that makes it happen," Carroll said. "These baby universes are literally parallel universes," Carroll said, "and they don't interact or influence each other." Carroll added more. "If that all sounded kind of trippy, it's because scientists have no way of looking back to even the moment of the Big Bang, let alone what preceded it. However, there is room to explore the detection of gravitational waves from powerful galactic collisions in 2015 opens up the possibility that these waves could be used to solve fundamental mysteries about the universe's expansion in the first crucial second. Theoretical physicists also have work to do," Carroll said, "such as making more accurate predictions about how quantum forces like quantum gravity might act. We don't even know what we're looking for," said Carroll, "until we have a theory. Some things remain a mystery to all people. We hope that our scientists solve these mysteries very soon." And with that, we've come to the end of our video. Share your thoughts with us in the comments below, and don't forget to give this video a thumbs up, subscribe to our channel, and we'll see you next time. Thanks for watching and goodbye.